Hey guys, I'm Bill. Welcome to today's human nutrition class. So in our last class, we talked about the respiratory system. We talked about the main structure and the main organs in the respiratory system, which are from the diaphragm, diaphragm, and we talked about the main function of the respiratory system, which is the exchange between the carbon dioxide and the oxygen. And the most importantly, we talk about the two zones in the respiratory system. Uh, by depending on the different functions of the zones, the respiratory system can be divided into two different zones, and each zone play a very important role in the respiratory system. And both of these zones are very important for the gas exchange and the whole function of the respiratory system. So today we'll talk about more details about these two zones, and we'll talk about some new knowledge. Yeah, we'll cover up some new stuff. But before we talk about today's topic, let's talk about several questions real quick. So the main function of the respiratory system is what? Basically the exchange of the gas. We breathe in the oxygen and breathe out the carbon dioxide. Yeah, so inhalation of the oxygen and the exhalation of the carbon dioxide is basically what the respiratory system do for our bodies. And what are two zones of respiratory system? So one will be the conducting zone and the one will be the respiratory zone. Conducting zone does not directly involving the gas exchange, but respiratory zones there is directly involving the gas exchange. Okay, so let's back to today's topic. So let's first talking about the conducting zone. Conducting zone provides a road for incoming and outgoing air, remove debris and pathogens from the incoming air, and warm and humidify the incoming air. So when I talk about that conducting zone is not directly involving the gas exchange, so some students will think that, oh, so conducting zone is not that important, but actually conducting zone is still important too because it plays a different but vital function in the respiratory zone, in the respiratory system. So, what function does it play? And I just told you guys. So, it provides a road for incoming and outgoing air. Yeah, there's a path for the air to be exhaled and to be inhaled. Also, it removes the debris and the pathogens from the incoming air because the air outside, the air in the world is it cannot be like guaranteed always clear, and it is very common that the air pollution is very common, so it cannot avoid to we cannot avoid a lot of debris and the pathogens in the air, especially in the areas with air pollution. However, our conducting zone clean the air for us, and we finally breathing the clean air. Also, we cannot guarantee that always the air will be warm and moist. So, there are some like in winter, in cold weather, the air will be freezing, and if we just breathe the freezing air, it will hurt our lungs because our lungs is about our body temperature, 37 degrees And the freezing air is like much lower than the 37 degrees. So we don't want to breathe in the cold airs, but we don't have any ways else to help warm these ears. Fortunately, our body structure, our respiratory system has a conducting zone that can help us warm the freezing air. Also, it can humidify the air, the incoming air. So these functions are very important for body health, and without these functions, we will get a lot of diseases, some very severe diseases, especially diseases about the lungs, and even to the death. The epithelium of the nasal passages, for example, is essential to sensing odors, and the bronchial epithelium that lines the lungs can metabolize some airborne carcinogens. Yeah, so these are just some examples that epithelium of the nasal passages, and it is involving the conducting zone as well as the bronchial epithelium, and this is how they work in the conducting zone. Yeah, the conducting zone is not an individual; it is composed of a lot of organs and tissues. The conducting zone includes the nose and its adjacent structures, the pharynx, the larynx, the trachea, and the bronchi. Yeah, and as the right figure shows, it shows some structures and organs that belongs into the conducting zone. It also labels the structures. It also labels the position of these organs or tissues. Yeah. And the second one I want to talk about is the respiratory zone. So the respiratory zone includes structure that are directly involving the gas exchange. The gas exchange is about the just simply just breathing of the oxygen and breathe out the carbon dioxide. The respiratory zone begins where the terminal bronchioles join a respiratory bronchiole. Yeah, as the right picture shows, the respiratory bronchiole is the smallest type of bronchiole, which then leads to an alveolar duct. Opening into a cluster of alveoli. So maybe you guys are still confused by only reading this text, but you can establish a very good understanding through the right picture. So the respiratory zone begins in the respiratory bronchiole, the top one, the top one, and then they go to the alveolar duct, the middle one, and the alveolar duct connects to the alveoli, and which is the bottom one. Yeah, so this is the respiratory zone, and next, we will go to talk about the alveoli. Yeah. So alveoli is just these structures like a small bubbles. Okay, alveoli. An alveolar duct is a tube composed of smooth muscle and connective tissue, which opens into a cluster of alveoli. So, where is the alveolar duct? Yeah, the middle one, and the alveolar just connects to the alveoli. And this tube is composed of the smooth muscle and the connective tissue, and yeah, it opens into a cluster of alveoli. Yeah, alveoli is not only the individual one; it has a lot of alveolus, which is a cluster of alveoli. And maybe some of you guys are confused between alveoli and alveolus. They are all same, but one is the simple form and one is the complex form. They are all the same. They both indicate the small sacs, small bubbles. And alveolus is one of the many small grape-like sacs that are attached to the alveolar ducts. As the right picture shows, these are the alveoli, which is also known as the alveolus. An alveolar sac is a cluster of many individual alveoli that are responsible for gas exchange. So if you look at the right picture, also you can look at this picture, you can see that the alveoli is always not the individual. It has a cluster of alveoli. So how do we call, what is the name of the cluster of alveoli? What is the name of the group of the alveoli that is attached closely each other? So the name of the cluster of alveoli is called the alveolar sac. And an alveolus is approximately 200 micrometers in diameter, with elastic walls that allow the alveolus to stretch during air intake, which greatly increases the surface area available for gas exchange. So first thing we need to understand is the diameter of the alveolus. So the diameter of the alveolus is 200 micrometer, and this unit we just talked about it in the chapter one, but we just don't have an idea about the 200 micrometer, how big it is. It's yeah, just look at your hair, and just one hair, the width of the one hair, the average width of the one hair is between 20 to it's between 20 and 200 micrometers. So that means even though you have a very wide hair, just a 200 micrometer, and this is how big your alveoli is. Yeah, so it's pretty small. um, and uh, and then we need to make sure that we know that alveoli has some elastic walls that allow the alveolus to stretch during air intake. So for understanding this concept, you can imagine the alveoli as the balloon, and you can imagine the elastic walls as the surface of the balloon. So like if you breathe in the oxygen into the balloon, it will stretch, and the surface area of balloon will definitely increase. Yes, right? So this is how the alveoli works. When the oxygen enters into the alveoli, the surface, which is the elastic walls, can be stretched, and the surface area is increased. And the main function of this increasing surface area is available for gas exchange. So that's why we say the alveoli is the organ that are associated with the gas exchange directly. Alveoli are connected to their neighbors by alveolar pores, which help maintain equal air pressure throughout the alveoli and the lung. Yeah. So the equilibrium of the air pressure in the lung is maintained by the connection between alveolus. Yeah, and actually you can look at the right picture. We have the alveoli, and we have the alveolar pores, and this is the pores that connect each alveoli together and finally form the alveolar cluster, which is the alveolar sac. And as a major organ of the respiratory system, each lung, yeah, so like we just kind of finished talking about the alveoli, and we just jump to the lungs. So lungs, we everybody know it. I think everybody know it. So the lung is very important organ in our whole body, and I think everyone know that the lungs main function is about the gas, the gas exchange. Yeah, the breathing, the breathe out is all involving the participation of the lungs. So, as a major organ of the respiratory system, each lung houses structures of both the conducting and the respiratory zones. So, we have the two lungs, right? And each lung has the conducting zone and the respiratory zone. The main function of the lungs is to perform the exchange of oxygen and carbon dioxide with the air from the atmosphere. Yeah, so it's easy to understand, and that's why that's what our lungs do. To this end, the lungs exchange respiratory gases across a very large epithelial surface area, about 70 square meters, that is highly permeable to gases. So the surface area of the lungs is very highly permeable to gases, and this is where the 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 the, the gas exchange appears. And the 70 square meters is like 1/4 tennis court, so it is pretty big, and it just our little lung in our body, and the surface area of this little lung can be considered as the force of the tennis court. So it's amazing. It's really surprised. It's really shocked me. But anyway, this is the general idea we talk about today. So we talk about the alveoli today, and we talk about how they connected, the structure of the alveoli, and the position of the alveoli in the lungs, and we talk about the lungs. Yeah, and actually, yeah, maybe I forget one thing to talk about. As the figure show, and you can actually detect that the alveoli is actually located in the lungs. So that's why we need to mention the lungs when we talk about the alveoli. And we talk about the lung, and we talk about the lung's main function, and we talk about where the gas exchange occur. Yeah, the surface area of the lung, which is about 70 square meters, which is the fourth of a tennis court. And yeah, I think nothing else. So this is the all content we talk about today. Thank you so much for watching my video, and Bill, see you next time. Bye bye.